This problem is a little more involved. I just took it out of the book. They do give you the picture. So if you want to go in the book, it is problem 44 in section 3.9. Maybe their picture probably looks a little bit better than mine. But for what it's worth, here we are. So this problem is a little more involved. You've got two carts, A and B, and they're connected by a rope 39 feet long, passes over a pulley. So here's the pulley. This rope is 39 feet in total. And Q is the point underneath the pulley. So basically what's going to happen is this cart is being pulled out this way, and because of the rope, this cart then is moving as well, right? So cart A is being pulled away from Q at a rate of 2 feet per second, and they're asking you how fast is the cart B going to be moving toward Q at the instant when cart A is 5 feet from Q. Okay, so I need some stuff here, right? This is 12, we know that. And we have to give these lengths names. So this is, I'm just going to call this little a and little b for cart A and cart B. This can be C and that can be R, sure. All right, fine. So now I have some variables. And you can see immediately that you've got two right triangles involved here, right? So before we get that, let's figure out what it's asking. We're given that the cart A is being pulled away, so that would be at a rate of 2 feet. So dA dt is 2 feet per second. And they want the rate that B is changing, right? The rate that cart B is moving towards Q. So that would be dB dt when little a is 5. Okay? So, as I said, these are two right triangles. So we have the right triangles, a squared plus 12 squared equals r squared, and b squared plus 12 squared equals c squared. Okay, and the other piece of information that we have is that the rope that passes over the pulley is 39 feet long. So that's going to give me a relationship between R and C. So R plus C is 39. So we have 4 unknowns, kind of like 3 equations. And there's various ways that you can do this, but what I found the easiest is just to kind of keep them separate first and then move them together, because what we need is to find, given the information we have about the rate dA dt, we need to find dB dt in terms of dA dt. So that's going to be the goal, right? Because when I take the derivative of this thing with respect to t, all 4 of those are changing. All 4 dimensions are changing. So, and that's okay. But my goal is, because I don't really care about how R and C are changing, I need the A and the B. So let's see what we got and what we can do with this. So if I take the derivatives here, I have 2A dA dt equals 2R dr dt, and I have 2B dB dt equals 2C dC dt, right? And I also have this relationship between R and C, right? So if I look at this one and take the derivatives here, I'll also get a relationship between dr dt and dC dt. So I'm going to put that here. Dr dt plus dC dt is 0, right? So at least I can eliminate some stuff here. So what I'm going to do is, okay, I've got what I want is this in terms of that. And I've got this other stuff here, but then I also have a relationship between these two. So let's see. First of all, I can get rid of all these 2's. Let me see. I probably will just erase this so I have some space. So if I start with this guy, A dA dt, this is R dr dt, but R is minus, the dr dt is minus dc dt, so this would be minus R dc dt, right? And here's the dc dt. So if I solve this guy, this is going to give me dc dt equals b over c db dt. So that's the one I need. Now I can put this guy in there. So this is going to give me minus r times b over c db dt, right? Or divide through by the a, then the a dt is equal to minus r over a. So I have minus rb over ac db dt. So that is what I want. So how did I know? How did I come up with what to do that? So for that, like, what's the problem solving idea, right? I'm trying to figure out from the information given, I need to figure out this dB dt. That's what they asked for. And the only rate they gave us is the dA dt. So they didn't give us these other ones. So they were showing up in our equations, but we were able to eliminate them by using the relationships that we have between these different variables. So this one is a little bit more complicated just because we have to kind of mess with it until we get the desired result, right? Okay, so now that we have the relationship we want, I went the other way, right? Given this, I want that. So let me rewrite that. All right, guys. dB dt is going to be minus AC over RB dA dt. Yep. Okay. So now we have this, we want to plug everything in. So we still have to figure out what all these values are. Okay? We were given dA dt was 2, and we were given that A was 5. Okay? But we know enough from our 3 things here that we should be able to figure out all the rest of them, right? So if A is 5, you can even immediately see this is going to be a 5, 12, 13 right triangle, or you can go back up here and figure out what R is. So when A is 5, R is going to be 13. Okay, so I'll just put them up here, it might be easier to. Now when R is 13, we know the length of the rope is 39, so that's going to give me 26 for the other side. And now I can go and figure out what B is, or it's not going to be 5, 12, 13, right? Because this one's 26. So it's going to be something not so nice. B is going to be the square root of 26 squared minus 144. This was the, I did this, 532. Square root of 532, I can pull out, what is this? 532 is 133 times 4, so I can write it like that, but that's pretty much the best I can do. No, because 133, it's like 7 times 19, and I'm not gonna end up with anything good there. So that's going to be my B. Okay. And now I can just stick all that information in here. So A was 5 and C was 26 and R was 13 and then I have this 2 root 133 and DADT was 2. Okay, so I can just simplify a little bit here, this right? But it's not a really great number. A really great looking number there, minus 10 over the square root of 133 feet per second. This turns out to be something like negative 0.867, right, is what it is. So, and that's not, it seems like it's a reasonable answer. First of all, it's the right sign, right? It's negative because B is decreasing, whereas A is increasing. So DADT came as positive, so DBDT turned out to be negative. That makes sense. And it's like a little bit, it's in at least the same range, right? It's like around 1 and this one is 2, so okay, I'll believe it.